Hi all. So we will start today's session.
So we
So we will solve some questions that will help you in
solving
solving the week 5 assignment
analog
for analog
electronics.
electronic circuits.
So let us
So let us start.
so
So this is the first question.
here
Here
we have
we
this
have the circuit where transistors are stacked.
so these
So these
uh,
uh,
top two
top two
transistors
transistors are PMOS,
and
and
here they are
here they are
NMOS,
NMOS.
and we know
And we know
K
this
dash
K
is
dash is given
for both
for both NMOS and PMOS. VT is zero point 0.3.
length is 1
Length is 1 micrometer.
and we have to
And we have
find
to find
width such
width
that
such that the
current
current through all of them is 153 microamperes.
so
So
let us see
let us
how
see how to solve this one.
so I've
So I've
listed
listed all the values that they have given,
and this is
and
the
this is the
circuit.
circuit.
So
So
first let's
first, let
try
us
to
try
apply
to apply
KVL in this
KVL in
branch.
this branch.
So if we go
So
from
if we go from top to down,
will be
it will be
so here
so here it will be
source
source,
drain
drain, gate,
source
source, drain, gate, and it will be drain, source, gate, drain, source, gate. Okay.
so we will
So
go
we will
from
go from
here
here. One second. Yeah.
so we can
So we
write
can write
V
V
VS
VSGP. Okay.
2.5
2.5 minus VSGP.
so we have
So we have
accounted
accounted for
this whole
this whole.
then
Then
again
again minus VSGP
minus
minus
VSGP
VSGP.
so now
So
we are
now we
here
are here.
so this
So
is
this is, let's
current
say current is ID. So this voltage drop is IDR
minus
minus
IDR
IDR.
then
Then
again
again
it will
it
be
will be
PG
VGS.
here also
Here also
VGS
VGS
minus
minus
VGS
VGSN minus VGSN
equals to
equals
0
to 0.
so
So, okay.
so this
So
is
this is the
K
KVL equation here, and okay.
so we
So we would require to have this
ID value
ID value, right?
and
So
we know
and we know
ID is
ID is this
much
much.
so let
So
us
let us first
see what is
see what is given.
so
So
this is
this is what K dash, right?
K dash
K
P
dash N and
so
K dash P.
I want
I
to
want
write
to write
KN
Kn and
KP
Kp.
so
So
KN
Kn equals
K
to
dash
K dash. Let me write this.
mu n
Mu
C
n Cox by 2
by 2
into W by L,
right
right? So
and KP is
and Kp is
COX by
UP Cox by 2
P by LP
WP by LP.
so it is
So
given
it is given what is
3.15
3.15
into
into
WN is
WNS
WP by
WP by 4 by 4,
and this one
and
is
this one is
0.7
0.788
into WP
into WP.
okay I'll
Okay,
ignore
I have ignored LP.
L
L for
is
both is 1 micrometer, so I'll just write upon L. On L.
so if
So
we
if we do this calculation, it will also be 0.788
WP by
WP by L.
so both
So both
KN
this Kn
are equal to
are
KP
equal to Kp, and
also
also since
same current
same
flows
current flows through this branch ID,
thus
thus
ID
IDN equals to IDP.
so what
So
we
what
have
we
in
have in our ID
Kn
equations, Kn
VGS minus VT whole square,
VGS minus
and then
VT whole
we have
square.
KP
On here we have Kp
minus VT
VSG
whole
minus
square.
VT
This means,
whole square. So this means,
so since both these
so since
quantities
both
are
these
equal,
quantities are equal,
these are
these and
also
these are
equal.
also equal. That means VGS equal to VSG.
VGS
VGS n
equal
equal
to
to VSGP.
okay.
Okay.
So
So
now
now
what we will do.
what we will do.
So now let's come
So
back
now
to
let's come back to this top equation.
I'll
I
rewrite
will
it
rewrite it here.
2.5
2.5
4
minus 4
GS
VGS.
let's
I'll just write VGS
and VT
and let's say
minus I.
minus I naught R equals to 0. IDR, sorry.
So
So
I'll
I'll
rearrange it.
rearrange it. Okay.
Okay, so let
Okay.
us
So let us first find
this
this. Let's find
2.5
2.5
minus 4.
minus 4.
So what is
So what is
VGS?
VGS?
So if we
So if
see
we
the
see
equation
ID equation, ID is equals to
K
K
VGS minus
VGS minus VT.
this
This
implies
implies VGS equals to
VT
VT
plus
plus, sorry,
under root
under root
ID by
ID
K.
by K.
So I'll
So I'll
replace it
replace it here, 4
under root
under root
ID
ID by K
plus
plus VT
minus
minus
ID
ID R
equals to
equals
0.
to 0. So, and okay, what do we want?
So
So
uh,
uh,
I'll just
I'll just expand this 2.5 minus
4
4 under root ID we know is 153
microampere
microampere and
is
K is
uh,
uh,
3.15
3.15 into,
let's say
let's say,
WN.
WN.
Now
Uh,
minus
minus
4
4
VT
VT is
into
into
0.3
zero point 0.3
minus
minus ID is again 0.
okay, I'll
Okay,
write
I'll
this
write this micro as 0.153, 0.153 milli,
because it is
because it is also in milli, right?
0.153
0.153
into R
into R is given
79.
3.79.
So
So
the only
the
unknown
only
here
unknown
is
here is
this
this
WN.
WN.
So
So
let's
let
take
us take another page.
so
So we were at here,
ID.
ID.
So if
So
I
if I
uh,
uh,
solve this
solve
whole,
this whole,
I will
I
get
will get
4
4
under
under root
ID by
ID by
3.15
3.15 W
equals to
equals to 2.5 minus 1.2
IDR.
IDR.
If I
And if I
solve these
solve these values, I'll get ID
by
by
3.15
3.15 W as
W 0.18.
0.18.
Now if I
Or
take
if I take whole square and arrange it, I'll get WN equals to
1.5
1.5 micro.
so this
So
is how
this is how we will solve this part.
is there
Is
any
there
doubt
any
in
doubt
this
in
part?
this part?
No, sir.
Okay,
Okay.
so
So
let's
let's
see the
see
next
the
question.
next question.
Okay,
Okay.
so in the
So
next
in the
question
next
now
question now,
lambda is
lambda
given.
is given.
So I hope
So I hope
by now
by
you
now
must be
you must be
familiar with
familiar with
lambda.
lambda. Lambda is
Uh,
uh,
channel length
channel
modulation
length
factor.
modulation factor.
Okay.
Okay.
So what is the
So
small
what is the
signal
small
gain?
signal gain they have asked?
So
So
uh,
uh,
for any
for any
amplifier circuit,
amplifier
what is the
circuit, what
gain?
is the gain?
AV is
AV is
minus GM
minus
into
GM into
Z out.
Z out, right?
So we will
So
try
we
to
will
find
try to
both
find
GM
both
and Z
GM
out.
and Z out, then we can find the gain.
So it is the
So it is
easier
the
way,
easier way,
else you
else
would
you
need
would
to
need to
solve all the
solve all the
equations for
equations
all
for
these
all these
MOSFETs.
MOSFETs.
That is not
That is not
required.
required. So we'll
So
just
take this
take this
shortcut and
shortcut and
find G and
find
Z out.
GM Z out.
Okay.
Okay, so let us first find, let's say, Z out. So before this, let me write the formulas for GM. GM, okay, ID is equals to K VGS minus VT whole square. So del ID by del VGS equals to 2K VGS minus VT. This is GM. And we can also write it 2K under root ID by K. We can write VGS minus VT as under root ID by K. So it will become GM equals to 2 root K ID. And similarly, GD or G naught, whatever you call it, or let me write it like this. 1 by R naught equals to GD equals to lambda times ID. So I hope you know this is lambda ID equal to, sorry, K VGS minus VT whole square 1 plus lambda VDS. So if we solve del ID by del VDS, we get lambda times ID, that is GD.
Excuse me, sir. Uh,
Yes.
why we do why we do not use lambda factor in solving GM?
Uh, you may use, but it will just like complicate things. So we avoid it. You may use that. Let's say that will be more correct. Yeah.
Then GM is approximately equal to 2 under root K ID.
Yes.
Can we do this approximation?
Sorry, can we what?
Can we do this approximation in this question?
Yeah. In whole analog course, we take GM like this only. So we do not consider while calculating GM, we do not consider the channel and modulation part. And but it itself is there, that is why we have something as GD. But generally, GM is much greater than GD, so this approximation is fair.
Okay, sir.
Okay. So okay, so now we know these formulations. Now let's try to find out this Z out first. So the GM we already know, we know ID and K. So we can find GM. Let's find Z out. So let me see the circuit again. So here in this circuit, this is my circuit, right? So here I have output here. So I'll first draw this part of the circuit and try to find the output impedance seen from this part of the circuit. Let me copy this diagram. So the output will see impedance from here and from here. But since our circuits are equivalent top and bottom, I'll just calculate it for the bottom part, and then we can just consider an equivalent impedance here. So the impedance will be, let's say, if this is Zn, Zp. So Zo output impedance will be Zn parallel Ze. But since both are equal, so it will be Zn by 2, right? Okay. So why I'm calling this equal, the impedances are equal, like why Zn equal to Zp? It is because we have already found out like uh, the same current is flowing through this branch, and as well as the mobilities and mu into W, this factor is same for both top and bottom. That is why the overall resistance is same for both on top and down. Okay, so anyway, let us find Zn.
For that,
So for that,
draw simpler
I'll
circuit.
draw a simpler circuit.
So to find
So to find
seen from
impedance
this
seen
port,
from this port,
so what we do is we
so
apply
what we do is
voltage
we apply voltage
at this
source
port and
at this port
see
and
the V by I
see the
ratio.
V by I
So
ratio. So
let's
I'll apply,
apply
let's say, a
voltage
small signal voltage
VZ and
Vz and
take its current
take
IZ.
its current Iz.
All other nodes will be
All other
grounded,
nodes will be grounded for this AC
and
signal,
let's
and
consider this
let's consider this as
voltage here at V.
voltage here at Vx.
So if I write
So
the
if I write
universal
the
equation,
universal equation
V for this
ID for
for
this,
this
let's say
MOSFET,
for this MOSFET first,
GM,
GM
VGS,
VGS
GD,
plus GD
VDS. So this is
VDS.
our
So this
equation
is
for
our equation. So
this
for
MOSFET.
this MOSFET,
Current
so
flowing is
current flowing is
IZ, right?
IZ, right? This IZ current will flow here.
IZ equals
IZ
to
equals to
GM.
GM.
What is the
What is
VGS?
the VGS for this MOSFET?
It is
It is
0 minus
0
Vx.
minus Vx.
So
So
minus
minus
Vx
Vx
plus GD,
plus GD,
GD and
GD and VDS is
VZ minus
VZ
Vx.
minus Vx.
Okay, so
Okay,
this is
so
fair.
this is fair. Now
I'll write
I'll
the
write
similar
the
equation.
similar equation for this MOSFET.
Again, current
Again,
will be
current will
IZ
be IZ only,
to GM.
equals to GM.
Now this is
Now
also
this is
grounded.
also
This is
grounded and
also
this is
grounded.
also
So it will
grounded,
be
so it
0
will be 0
plus GD.
plus GD.
This voltage is
This voltage
Vx.
is Vx.
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 So this will
So
give
this will give me
Vx equals to,
Vx equal to Iz by GD,
and we will
and we will
substitute this into
substitute
this.
this into this.
So we will
So
get
we will get
Iz equals
Iz
to
equals to GM
minus
minus
Iz by
Iz
GD
by GD
plus
plus
GD
GD
Vz
Vz
minus
minus
Iz by
Iz
GD.
by GD.
So if we
So
take
if we
Iz
take Iz
common,
common, let's say Iz here,
1 plus
1 plus
GM
GM
by GD
by GD,
and here
and here
Vz
it will come
plus 1
plus 1, okay,
equals to
equals to
GD
GD
Vz.
Vz.
So if I
So if
rearrange
I
this,
rearrange this, I'll get this.
so what
So
I
what I
ultimately want
ultimately
is
want is
the
the
Vz by
Vz
Iz.
by Iz.
So I'll
So
find
I'll
that
find that. So
Vz by
Vz by
Iz
Iz
equals to
equals to uh,
GM
Gm by GD
plus 2
plus 2
divided by
divided by GD.
so if I
So
solve
if I
this
solve this, it will be Gm
plus
plus
2 GD
2 GD
2
2 GD divided by
GD square.
GD square.
So this is
So this is our,
so Z
let's
and
say, Zn that we are trying to find. So
this is
this
Z.
is Zn.
Now
Now
Zn was
Zn was
GM
Gm plus
G
2 GD
divided by
divided by
GD square.
GD square.
Is there any
Is
doubt
there
till
any
here?
doubt till here?
Sir, is there
No,
any
sir.
GMB factor in this?
I think it is
I think it is given in the question that there is no GMB. Let me check.
they have just
They
said
have
ignore
said
the
ignore
body
the
effect.
body effect.
Okay. It means source and body are connected to each other.
Yes,
Yes.
And
VSB is
I
VSB
have
is
a
0.
one,
yeah.
Yeah.
and I have one more doubt. Uh, how, how can you take voltage gain is equals to minus GM times Z out? Simply minus GM.
Okay.
Okay.
So
So,
so let us
let
say
us
where
say
my
where
input.
my input,
So input is applied
input
here.
is applied, let's say here, right?
So
So,
what will happen?
what will happen is
The trans
the
conductance
trans
that you will
conductance
get
that you will get
will
will
be only
will
from
be
this.
only from this transistor.
So this,
So this,
but the output
but
that you are
the
taking
output
from
that you
here,
are taking from here,
uh,
uh,
the impedance will be
the
seen
impedance will be seen
at
at
both sides of the
at
node.
both sides of the node. So
Uh,
uh,
ultimately, so you
ultimately,
can
so
solve it
you can solve it
using the equation that we
using
did
the
last time
equation that
also.
we did last time also.
So the final factor
So
that
the
you will
final
get will be this only,
factor that you will get will be
in
this
Z out.
only,
So GM
GM
is
times Z out. So
uh,
GM is
the
like
conversion factor. So
the
you
correct.
apply
So you
an
apply
input
an input
voltage V in here.
voltage V in
So
here.
through this
So
transistor,
through
this
this
V in is
transistor,
converted
this
into,
V in is
let's say,
converted
something
into, let's say,
I
something
in.
some I in, right?
So this conversion
So
of
this conversion of
V into I
V
in
in to I in
is is done by this
is
transistor's
is
GM.
done by this transistor's GM.
Then after that, this
Then
I
after that, this I in
is flowing through this
is flowing through
branch,
this
and
branch,
here
right?
let's suppose you
And
have an
here, let's suppose you
load.
have a load.
So here, what is
So
the
here, what is
total?
the total? Okay.
So here, what is the
So
total?
here, what is the total
Let's say voltage drop
voltage drop
this
across this
across this
across
load
this
will be
load will be
Z out
Z out
into
into
V in
V in
GM.
into GM,
V
right?
out will be,
V out will be
so V in into GM
V
is
in
the
into
current,
GM is the current,
and Z out is the
and Z out is the
impedance at this node.
impedance at this node.
That will be the
So that
total
will be
voltage
the
drop
total
here.
voltage drop here.
If we do V
So
out
if
by
we
V
do
in,
V out by V
we
in,
will get
we will
GM
get
into
GM
Z out.
into Z out.
Is it making
Is
sense?
it making
It is
sense? Like
very
it is very rough.
uh,
Uh,
I've told it very
I've told
roughly,
it
but
very
if
roughly,
you
but if
practically
you
solve it,
practically
you will
solve
get
it through the equations, you will get
similar
a
result.
similar result.
Okay, okay.
I think it
I
has
think it
been
has
talked
been
about in the
talked
videos
about in the
also.
videos
Uh,
also.
is that correct?
Is that correct?
Yes, I remembered. Sir told that uh, the current flowing through NMOS will go to the upper NMOS because it has low impedance. Will not go through the RDS of lower NMOS. So I think so. It has a transconductance equals to zero.
So
So
what
what
I'm
I'm
not
not
sure what
sure
you're saying,
what
but
you're saying, but
the thing
yeah,
is,
the thing is
we are applying
we are
input
applying
only
input
here.
only here.
So this is being converted
So being
into a
converted
small signal
into a
current
small
through this
signal current
transistor
through this
only.
transistor only.
That is why we get the
That is
GM
why we
factor.
get the
GM
GM
is
factor.
actually what?
GM is
The
actually what?
conversion of
The conversion of
V into I
V
in.
in to I in, right?
C what is GM?
See what is GM.
GM is del
GM is del
change
change
in
in
ID
ID
with
with
change
change
in
in the
voltage.
input
So that
voltage.
is
So
GM.
that is GM.
And once it is
And
converted
once it
into
is
this current,
converted into this
then
current, then
we are only
we
concerned
are
with
only concerned with what is the
how this current
how
is
this current is
reaching, like what is the
reaching, like what
resistance
is the
path for this
resistance path
current
for this current
to go to the
to
output.
go to the output.
How that is how
How
it
that is
comes
how
to
it
be
comes
GM
to be
into
GM into
Z out.
Z out.
And this minus
And this
term is
minus term
because
is
of
because of
this common
this
source
common
configuration
source
only.
configuration only. So
If you increase
if
this,
you
it will
increase this,
decrease
it
and
will
something.
decrease and something like that.
Is it
Okay,
Is
sir.
it? Yeah, okay.
Sir, I have one more question. Like
yes?
we can use directly Z out equals to which was given in the lecture video. Uh,
What
in
What
lecture
was it
video,
given?
सर told सर सर ने ये बताया था कि जो अगर मॉसफेट के नीचे अगर सोर्स के साइड अगर एक रजिस्टर लगा है तो उसकी इम्पिडेंस होती है looking from the drain side RDS
Yeah.
of MOSFET plus intrinsic gain of the MOSFET times RS plus RDS.
you're saying अगर
You are saying अगर ऐसा
एक
कुछ है,
रजिस्टर लगा
एक
है
रजिस्टर लगा है this,
Yes, sir.
और यहाँ से
और
हम
यहाँ
देख
से
रहे हैं
हम देख रहे हैं तो it will be
Z out equals
Z
to
out equals to what?
repeat
Can you repeat?
RDS
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 plus
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 intrinsic gain of the MOSFET GM plus GMB times RDS
GMV
times
times
RDS
RDS
into RS.
whole into
whole
RS.
into RS.
Yes. No, not whole. GM plus GM. GMD into R इंट्रिंसिक गेन के साथ मल्टीप्लाई हो रहा है RS.
Like clearly. This
Yes, yes.
okay, GMB
Plus
RDS
RS.
is together. Plus RS. This
Yes, yes, sir.
uh, let me see how this comes.
सर क्योंकि वो लोअर जो मोस्फेट है तो वो तो इजीली कन्वर्ट हो जाएगा RDS में.
So हम ऐसा करते हैं, सॉल्व करके देखते हैं इसको एक बार. तो मैं भी जैसे इसमें किया था, मैं भी इसमें भी एक वोल्टेज सोर्स लगाता हूँ VZ, लेट द करंट भी IZ. सो अब मैं इसकी अगर इक्वेशन लिखूंगा तो IZ इक्वल्स टू, लेट्स से दिस वोल्टेज इज VX. So current will be GM VGS GD VDS. I am ignoring GMB vector for now, simplicity के लिए. So GM VGS क्या होगा इसके लिए? It will be, it is grounded, minus VX plus GD VZ minus VX. Okay. Also VX is what? IZRS. Right. So I'll put it here. This will give me IZ equals to GM IZRS plus GD VZ minus IZRS. I'll copy it next page. So मैं IZ वाले सारे टर्म्स एक साइड ले लेता हूँ. IZ 1 plus GM RS plus ये टर्म आ गया, ये टर्म आ गया, ये रह गया, राइट, प्लस GD RS. ओके, इक्वल्स टू GD VZ. So VZ by IZ will be 1 plus GM RS, let's say GM plus GD RS whole upon GD. ओके, तुमने क्या बोला है? RS RDS plus. So RDS is nothing but RDS equal to 1 by GD. So अगर वो करके देखें 1 plus GM plus 1 by RDS RS divided by 1 by RDS equals to 1 plus GM RDS plus RS. यहाँ पे भी RDS हो जाएगा, ये भी RS आएगा. हाँ यही आएगा, राइट. राइट अगेन ये RDS को मेरे को अगर जैसे मेरे को इसमें से 1 by RDS कॉमन लेना है. सो दिस RDS will be first multiplied by this and this, right. So it will be RDS plus GM RDS dot RS plus RS. और यहाँ पे कॉमन है 1 by RDS और नीचे भी 1 by RDS. ये और ये कैंसिल हो गए और ये वही आ गया जो तुम बोल रहे थे. यही था ना. आई जस्ट इग्नोर GMB, बाकी तो सेम ही है. RDS plus yeah. So I don't think like RS को तुम्हें कोई ट्रांजिस्टर को एज RS एक रजिस्टर रिप्लेस करना चाहिए, बट हाँ तरीका यही है निकालने का जो मैंने बताया.
तो सर उस सर्किट में वो जो नीचे लोएस्ट ट्रांजिस्टर है एनमॉस,
हाँ,
उसको अगर आरडीएस से रिप्लेस कर देंगे तो इस इक्वेशन में हम पुट कर सकते हैं।
नहीं क्यों,
नहीं,
कैसे
क्यों,
रिप्लेस
कैसे
कर सकते
रिप्लेस कर सकते हो तुम किसी पूरे
आरडीएस?
ट्रांजिस्टर को आरडीएस से?
सर अगर देखें ड्रेन की साइड से उसको देखें तो वो आरडीएस की तरह बिहेव कर रहा है।
बट
बट
दिस
दिस
ऐसा नहीं
ऐसा
होता,
नहीं होता बिकॉज लाइक
नीचे
नीचे अब एक
ट्रांजिस्टर है,
ट्रांजिस्टर है,
तो
तो
Sir, I think this is valid when the gate is grounded for the lower transistor.
ओके।
ओके,
But here it's input to the gate, so I think we cannot directly do that this calculation.
सर आई एम टॉकिंग अबाउट इम्पिडेंस। इम्पिडेंस में तो सारे इनपुट हट जाएंगे।
इम्पीडेंस वी टेक
impedance we take gate is grounded.
सो या
So yeah, like it is fine. So यहाँ पे मैंने निकाला, अगर जैसे this voltage was what Vx was
आई जेड
Iz
बाई
by
जी डी,
Gd,
एंड जी डी
and
इज
Gd is nothing. Right.
दिस वी
This
एक्स
Vx equals to
आई जेड बाई
Iz by Gd, right?
और लेट
Or
मी
let me write Iz into RDS.
या
Yeah.
सो
So
हियर इट
here
इज
it is RDS only.
maybe
So
you can
maybe you can try doing that, just
replacing this
replacing
by
this by
resistance of
resistance of
RDS,
RDS.
then you
Then
should
you
get
should get
the same
the
result.
same result.
So if you
Sir,
So if you
instead of writing all this equation, we can do this.
yeah,
yeah,
I
you
have
have I have
simply done
simply done that only.
like
Like
I just
I
written
just written it as VXIZ.
this is
Like this is
same as
same
this.
as this, right?
Mhm.
If I'm
If I'm
writing a
writing a
potential drop here,
potential
you
drop
would
here, you
also
would also
have to
write
take
have
this
to take this
VX.
VX
So I
anyway. So
just
I
you have
just you have
I'm writing
I'm
it as
writing it as
GD, you will
GD.
write
You
it
will
as
write it as
RDS.
RDS.
The same
The
thing.
same thing.
Yes.
Okay.
Anything else?
Anything else here?
Okay, so
Okay.
let's
So
move
let's
ahead.
move ahead. Let me add another page. Okay.
I'll just
I'll
add a
just add a
page.
page here.
So
So
this was
this
our
was our Zn.
ZN
Zn equals to
GM plus
Gm plus
2GD
2Gd
by
by
GD square.
Gd square.
So Z
So
naught
Z
will
naught
be
will be
ZN
Zn parallel Zp
ZN by
Zn by 2 equals to
GD by GD square.
2Gd by
Z
Gd square.
AV is
Z naught and AV is
Z naught. So
minus
when you
Gm Z
solve
naught.
this
So
finally,
when you solve this finally,
we know all the
we
values.
know all the values because
GM we can
Gm
calculate,
we can calculate. We know
ID we know
ID, we
K,
know K,
and we also
and
know
we
lambda.
also know lambda and we know ID. So if I just write it, I'll get
GM value
GM value will be, let me see if I have that solved.
GM will
GM
be
will be
1.7,
1.7 millisiemens and
GD will be
GD will be
0.0153.
0.0153 millisiemens.
So when we solve
So when
this,
we solve
will
this,
be
AV will be
minus
minus
6232 something.
6232, something like that. Yeah.
So
So, okay.
this will be
Let's
answer
do the option here.
this answer.
This answer.
Okay,
Okay,
so
so
is there
is
anything
there
else
anything
you want
else
to
you
ask?
want to ask in this
Else we'll
question?
move
Else we'll
ahead.
move ahead.
We can move, sir.
Question 3,
Question 3,
solve it
I'll
later.
solve it later
It's
because
not
it's not
very,
very,
it's
it's
conceptual. I'll
conceptual.
solve,
I'll
let's say,
solve, let's say, question,
some
some
important
important question. Let me see.
less
We
time.
have less time. We'll
First
see
we'll
the
do
important ones first. Um,
let's solve
Let's
question
solve
6
question 6
first.
first.
Then we'll
Then
come
we'll
back
come
to
back to 4
4
and
and
3.
3.
Okay.
So
Okay.
in this
So in this question, uh,
you have to
you
find
have to
this
find
current
this current.
I copy.
I copy.
Let me
Okay.
solve
Let
this
me solve this one
because
first
this is
because this
easier
is
to
easier
understand.
to understand. Yeah.
So this is a
So this
current
is a
mirror.
current mirror.
If this
We
IRF
know
is
this,
flowing
if
here,
this IRF is flowing here,
uh,
uh,
a ratio of
a ratio of
this width.
across this width.
Let's
Okay,
solve.
I'll just solve it.
Let's say
Let's say
IRF is the
IRef
current
is the
flowing
current
through
flowing
this
through this transistor. So IRef will be
mu and
mu n Cox
AW1
AW1
by L
by L
VGS
VGS
VT
minus
whole
VT whole square.
and
And
I
I
let me call it
let me call it I2.
I2 will be
I2 will be
mu and
mu n Cox
BW1
BW1
by L
by L
VGS minus
VGS minus VT
whole square.
whole square.
Now
Now,
same
same, they both have the same gate voltage. So
if I take the
if I take the
ratio
ratio,
IRF by
IRef by
I2,
I2,
so these
so
will
these
cancel
terms will be get cancelled and these also will be getting
so I'll
cancelled.
get
So I'll get
equal to
equal
A
to
by
A
B.
by B. So
I2
I2
equals to
equals to
B by
B
A
by
times
A
IRF.
times IRef.
This
So
current will
this
be
current will be B by A times IRef. B by A
IRF.
IRef. Okay.
Now
Now
this current is
this
flowing
current is
through
flowing through this transistor also, and
ultimately you have to find
ultimately you have to find I copy.
so I
So
copy
I copy
will be
will be
similarly
similarly D by C times
I2.
I2,
I2 is what?
and I2 is what?
T by C times
T by
B
C
by
times
IRF.
B by A times IRef,
Right.
right?
So values are
So
given. It will be
values are given. It will
let me
be,
put it here.
let me put it
D
here.
is what?
D is what? D is 1,
C is 3,
C is 3,
B is 4,
B is 4, and
and
1.
IRF is
IRF is 553
microampere. If
microampere.
we solve
So
it,
if we solve it, we will get, what will we get?
737
737
which is
microamperes,
the
which
answer.
is the answer. This.
So is this
So is this clear current mirror?
so this
So
segment is
this
a
Yes,
current
segment is
sir.
a
mirror
current mirror,
and this segment
and
is
this
also
segment is also a PMOS current mirror. Okay,
so let us
so
quickly
let us
solve this
quickly
one.
solve this one also first.
So here
So here
similarly
similarly
we can
we
find
can find I2 will be same, right? It will be,
it's
let me write here,
B by
B by A times IRef,
and this
and
current
this current, let me call it I3.
I3 equals
I3
to
equals to
E by
E by D
dot
dot
B by
B
A
by A times IRef,
and this
and
current.
this current.
So
So
here if you
here
see
if you see
now
now,
this is a
this
current
is a current mirror, this
and this.
and this.
So this
So
current
this
will
current
be
will be,
let me call it
let me call
I4.
it I4.
I4 equals
I4
to
equal to
C by
C
A
by
times
A
IRF.
times IRef.
So I
So I
copy
copy is what?
I3
I3
minus
minus
I4.
I4.
It is
It is,
let us take
let us
common
take common IRef,
E by
E
D
by D,
B by
B
A
by A
minus C by
minus
A.
C by A.
So anyways
So
now
anyways, now you can solve this.
I have the
I hope the
concept.
concept is clear, right?
So answer
So
will be
answer
this
will be
one.
this one. Yeah.
If you put all the
If you put all
values.
the
Sir,
values.
Yes.
sir, in
Yes.
this problem, can I say I4 will be divided by I4 is equal to IRef by 2. Why? Because it's two transistors are connected, A and B.
Why IRF by
Why
2?
IRef by 2? I don't get it. Sorry.
Why? Because it's two transistors are connected back to back. So
No, no, no. That.
when we say I,
So are you saying like this? So
So are you saying like this?
this is my
So
current
let us
mirror.
say this is my current mirror.
yeah,
Then
Then
if I
if
take
I
the same
take this
node
same node
voltage
voltage connect another NMOS.
So what
So
this
what
essentially
this
means,
essentially means, so if I connect, let's say I connect more,
connect 10
I
more
connect 10 more NMOS. I cannot connect like this.
so
So
let us say both
let us
have
say both have
same
all
width.
have same width, W, W, W.
So
So
since all have
since
same
all
width
have same width
and all have the
and
same
all have
gate
the same
voltage,
gate voltage, right?
so whatever current is
So
flowing
whatever
through
current is
this
flowing through
reference
this
transistor
reference
IREF,
transistor IREF,
it will the same
it
current
will
will
the
flow
same current will flow through
all will have IREF,
all will have IREF,
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 IREF.
IREF.
Why that is that
Why
happening?
is
All have
that
same
happening?
gate
Because
voltage
all have same gate voltage
and same width.
and same width.
Now in
Now
this
in this
question, what
question,
we were
what
doing,
we
we
were
were
doing,
just
we were just
changing the
changing the
widths.
widths.
Then we get the width B
That
by
is why
A.
we were getting these ratios, B by A or E by D.
So these
So
transistors
these
current
transistors,
will
like
not divide.
current will not divide among these
Current will
transistors. Current
copy.
will copy.
That is why it is called a current
That is why it
mirror.
is called a
Mirrors
current
the current.
mirror. It mirrors the current.
Uh, does that make any sense?
Uh, does that make
Yes,
any
sir. Okay,
sense?
sir. Correct.
Okay.
So I hope this question is clear.
So I hope this question is clear.
Let us
Uh, Let us try and solve question number.
let's solve question number 4.
Let's solve question number 4.
Okay.
Okay.
So in this question
So
we
in
have
this question, we have to find what do we have to find? Atmosphere,
what is current I.
what is current I? This current.
Okay.
Okay.
So again
So again,
if we
if we see here,
so let's say
so let's say current flowing through here is
I not.
I naught. Let's say.
So current flowing
So
through
current flowing through here will be 21 I naught
because it is
because
21
it is 21 times.
here,
And
but here also it
here
is I
also
naught.
it is I naught.
Current here will
So
be I
current
naught.
here will be I naught only. So rest
20 I naught current
20 I naught
here,
current goes to here.
and again these two
And
widths
again
are
these two
same.
widths are same. So this
I is
I
equals to
is
20
equals
I
to
naught.
20 I naught.
So we have to
So we
only
have to
find
only
this
find
current
this
I
current
naught.
I naught.
Then we can
Then we
easily
can easily
get this I.
get this I equals to 20 I naught.
So we
So
essentially
we
have to
essentially
find
have
the
to find
current
the
through
current
this
through this
resistor.
resistor.
For
For
that we
that
need
we
these
need
two
these two
terminal
terminal
voltages.
voltages.
So let's
So
say
let's
I
say
naught will
I
be
naught
equal
will
to,
be equal to,
let me call
let me
it
call it, what should I call it?
VG1
VG1
and
and
VG2.
VG2.
So I naught
So I
equal to
naught equal to
VG1
VG1 minus
VG2
VG2
by
by
R,
R,
right?
right?
Okay.
Okay.
So
So
first we have to
first we
find
have to find VG1. Okay.
so for
So
this
for this
PMOS
PMOS
device
device,
I
I
I naught
I
equals
naught
to
equals to
KP
KP
VG
VG
VS
Vs
minus VT
minus VG
VT
minus
whole
VT
square.
whole square.
I naught
I
equals
naught
to
equals to KP.
VS is
Vs is what?
uh,
Uh,
2.5
2.5.
VDD
VDD equals to 2.5 volts
minus
minus
VG1
VG1
minus
minus
VT
VT is what?
let it be
Okay, let
VT
it be VT only for now.
whole square. So
Whole square. So
2.5
2.5
VG1
minus VG1 minus VT equals to under root I naught by KP.
and
And
VG1
VG1 equals to 2.5
under
minus
root
under
I
root I naught by KP
minus VT.
minus VT.
This is
So
VG1.
this is VG1.
And
And
similarly for
similarly, VG2,
we will
for we will consider this transistor
we will
and we
get
will get
VG2
VG2
to
equals to
under root
under root I naught
KN
by Kn
plus VT.
plus VT.
This is
Okay,
VG2.
this is VG2.
And
Now I is
I naught is
I naught is
VG1
VG1
minus
minus
VG2.
VG2.
Just
Okay,
write
I'll
the
just
values.
write the values now.
2.5 under
2.5 minus
root I
under
naught
root I naught
by
by
KP
KP
minus VT.
minus VT.
This is
This is
VG2
VG1. Vg1 minus
VG2 is
Vg2 is under root
I naught
I
by
naught by Kn
minus
minus Vt
VG2
Vg2
whole divided
whole
by
divided by R.
okay.
Okay, so
Let
let
us
us try to solve it this way.
I naught
I naught R equals to 2.5
minus.
minus.
So we had
So we
already
had already solved for. Uh,
yeah.
okay, we have not found.
So mu
So
n
mu n
Cox by
Cox
2
by 2
is
is
equal
equals
to
to 80.
L
Okay, I'll multiply W by L also.
Wn by
Wn by Ln
equals to 80
equals to
micro.
80 micro
W1 is 10 micro
into W1 is 10 micro
and 1 micro.
and
So it will
length
be
is 1 micro.
800
So it will be 800 uh,
micro Simon per volt.
micro Simon per volt.
This is for K. Kp will be
And this is what
mu
mu p
Cox
Co
by 2 Wp by Lt up to 40 micro
micro
and Wp is into 20.
and WP is into 20.
So it will also be 800
LP is same. So it will also be 800 microsiemens per
Kn
volt.
equals to Kp.
So Kn equals to Kp.
We combine this. This is
So
2
we will
under root
combine this. This will be 2 under root I naught by let's say
minus 2
Kn minus 2 Vt.
So
Okay.
it is
So
it will be
it
difficult to
is
solve
it will be difficult to
because it is
solve
not
this
exactly
equation because it
quadratic.
is
So
not
what we will
exactly
do is we
quadratic.
will
So
assume
what we
let's
will
say
do is we will
under root
assume
I
let's
naught
say under
equals to
root I
x.
naught
So
equals
this
to x.
I naught
So this implies I
x
naught
square.
equals to x square.
So our equation
So
will
our
be
equation
x
will be
square
x
r
square r
2.5
2.5 minus
2
2
x by root k.
x by root km
Now this
minus
quantity
2Vt.
we can solve.
Now this quadratic equation we can solve.
If I put the
So if
values,
I put the values,
if I solve it, I
if I
will get
solve it, I will
I
get
naught equals
I
to
naught equals to
0.12
0.12
milliampere
milliampere
and
and
our current this
our current
that we have to
this
find
current that we have to find 20 I naught will be
2.55
2.558
milliampere.
milliampere.
Is this clear?
Is this clear?
Yes, sir.
So this equation will give me x, so I will have to
Yeah.
take
So
x
this
square.
equation will give me x, so I will have to take x square to find this I naught, right? This is x square.
I think it will be something 0
I
0.01
think it will be something 0.01 something, yeah,
something like that
0.11,
0.11
something like that,
equals to
0.11 x equals to.
I don't remember
I
exactly. I
don't
solved it.
remember exactly. I had
So
solved it, but
easily
yeah,
solvable.
you can easily solve it. It
Solvable.
is solvable. Okay.
So we have a few
So we
minutes
have
to
a few
solve
minutes. Let's
question
solve
3.
question 3. Okay.
So we
So
have to find
we have
swing.
to
So
find
for
swing.
that,
So for that,
what is swing
so
is
what
we
is
have to
swing is
find
we
the
have to find the
maximum
maximum
change,
change,
allowable
the allowable
change here,
change
so that
here,
all the
so that
transistors
all the
remain in
transistors remain
saturation.
in saturation.
So
So
let us take
let
this
us take this question.
this
Okay,
node.
this node.
So this is
So this is a diode
so let's
connected. So
say
let's say
the
the
potential drop
potential
here.
drop here. Okay.
So
So
let us consider
let us consider
VOV
VOV equal to
VGS minus
VGS minus VT. That is the overdrive voltage. I hope you know this overdrive.
so
So
this
this
voltage
voltage is plus minus, let's say
VGS
VGS.
and what we
And
need
what we need here is
voltage here should
voltage
be
here should be greater than VGS minus VT,
right.
right?
VDS
VDS
should be greater
should be
than
greater than equal to
VGS minus
VGS minus VT.
yeah.
Okay.
So
So
we can write
so
it
we
as
can write it as
so VDS
so VDS
greater
should
than
be greater than equal to VOV.
VOV.
So VOV is greater than equal to VGS minus VT. So
VGS
VGS equals
equals
to,
plus
let's say, VOV plus VT.
so
So let me erase this.
the voltage here
The
is
voltage here is VOV plus VT.
similarly
Similarly,
we will need a
we will
similar
need a
voltage
similar voltage here, so it will be VOV plus 2VT. Right.
sir has also
Sir
taught
has
this
also taught this in the video. I'm just
reiterating
reiterating it. Okay.
anyways.
Anyways,
So
so okay.
so if this
So
is
if this is
VOB plus
VOV plus VT and this is VOV, oh
2
sorry,
VOB
2
plus
VOV plus
2 VT,
2 VT,
then
then
what should be the
what should be
voltage?
the voltages here and here?
Let me take a
Let me
different
take a
color.
different color here and here.
So
So
if the voltage
if
is
the voltage is here,
VOB plus
VOV plus VT, so to keep this
transistor in
uh,
saturation,
transistor in saturation, we can keep this voltage as
plus VT
VOV plus VT
plus
only.
VT,
VOV plus VT,
there will be another
and
VOB drop across this. So
there will be another VOV drop across this. So
VOB
this voltage will be
VT.
2 VOV plus VT.
Sir, is this the minimum value?
Uh, yes, the minimum value to keep
Yes, the minimum value to keep these transistors in saturation is
minimum
this,
value that
the
we can
minimum value that we can have
Okay.
here.
So similarly, if we solve from top,
So similarly, if we
we
solve
will
from
get
top, we will get, let me change the color.
the maximum that value that
The
we can have
maximum that value that we can have here will be given from here. That will be
VDD minus 2 VOB.
VDD minus 2 VOV minus
So this is
VT.
the maximum,
So this is the maximum
the minimum.
and this is the minimum.
So the swing is
So
the difference
the swing
between
is the difference between these, the maximum and the minimum.
swing will
So
be
swing will be
VDD minus 2
VDD minus 2 VOV
minus
minus VT minus
2 2 VOB.
2, okay, let
So it
minus
will be VDD
2 VOV
minus
minus
2
VT.
VT minus
So it
4
will be
VOB.
VDD minus 2 VT
VDD we know
minus
is
4 VOV.
VT is
VDD we know is 2.5,
no VOB we will
VT is
have
zero
to
point 0.3, so minus 0.6. No, VOV we will have to find. So ID we know, ID equal to K,
VOB equals to under root ID by K.
ID by K.
So
So
ID was
ID was
0.1
0.153
K
and
was
K was, what was K?
zero point
0.788 WP by
0 point
0.15 W by
zero point 5 by
0 point by LN. They have not given W by L information.
okay. So
Okay, so we can find that.
we have
So we have already know uh,
in this
in
question
this question we have found
W
Wn
and Kn
and
was
Kn
given
was given, Kn and dash
was given
was given to be
this
this
3.15.
3.15.
So we can
So we
find
can find Kn.
Kn equals
Kn equals to Kn dash
to W.
into W.
So
Anyways,
Yeah, so we can find VOE.
So
I don't know the value right now.
yeah, so we can find VOE.
4 times
I
VOE.
don't know the value right now, but yeah, you can find, so it will be 4 times VOV.
So you can get the swing.
So you can get the swing.
Is this question clear?
Yes, sir.
Okay.
Sir, I have doubts, sir, regarding this notation.
Yes.
What is the difference
Yes.
between the notation Cox and Cox prime?
Let me check.
Okay, let me check.
So in all the problems, un Cox prime by 2, that way it is given. So in the expressions for ID, we write Cox simply. How the Cox prime and Cox are different?
I'm not
I'm
sure.
not sure. Yeah.
I'm not sure why they are
Why
writing
they are
CX.
writing Cox
We'll have
prime?
to
I'll
check.
have to check that.
We'll
I'll
try to find
try
that
to
and
find that
post
and
it
post it
along with the
along
video.
with the video.
Okay, sir. Okay, sir. Thank you, sir.
But for
But
all
for
these
all these
questions, I have
questions, I
taken
have taken
CX prime
Cox
as
prime
CX.
as Cox, like
Same thing.
same thing. So this
You can
you can
solve this,
solve
but
these, but
I'll find
I'll
out the
find out
difference
the difference
why they have
why they have
taken this
taken this
notation.
notation.
Okay. Okay.
Is there any
Is
other
there any
question
other
you want me to
question you
solve
want me to solve
from this
from this assignment?
Sir, eighth one, sir.
example?
Eighth.
Let us
Okay,
solve
let
it.
us solve it.
So eighth is
So
simple.
eighth is
If you
simple.
know
So if you know about an
op amp in
op-amp
negative feedback,
in negative feedback,
so if
so if
due to
so
virtual short,
due to virtual
these two
short,
nodes are
these
equal,
two
right?
nodes are equal, right?
So if this is
So
grounded,
if
this
this is
will also be
grounded,
grounded. So
this
you
will
know
also
this
be
concept,
grounded.
virtual short.
So you know this concept,
Yes, sir.
virtual
Yes.
short. Okay.
Okay. So in this, so
Okay.
this is
So in this, so this is since this is grounded,
Yes, sir.
this will also be grounded. Okay.
here both
And
these
here both
NMOS
these
have the same
NMOS have the same
V
gate
by
voltage, right? V
same
bias, V
source
bias,
voltage also. So
and
both,
same source voltage also. So both will have the same current also.
if this is I out,
So if
here
this is
also it
I
will
out,
be I out,
here also it will be I out only,
right? So if
right?
I apply
So if I apply KCL at this node,
this node,
in
what
this
I will
node,
get
what I will get
V in minus
V in
0 by
minus
R
0 by R
equals
uh,
to I out,
equals to I out, right?
I out
I out
V in by R.
to V in by R.
And what we have to
And
find?
what
We have to
we have
find
to find? We have to find
transconductance.
transconductance.
Transconductance is what?
Transconductance is what?
Del I out
Del I out
by del V in.
by del V in.
It will be
It will be
1 by R.
1 by R,
R is 1
and
by
R
16.
is 1 by 16.1 kilo
So
ohms.
this will be the answer.
This will be the answer.
So if you solve this, we will get
So if you solve this, we will get, I think,
it is
yeah, it is
62.112 microsieverts.
62.112 microsieverts.
Is this clear?
Is this clear?
Yes, sir. Yes, sir.
Yes, sir. Sir, I have doubt regarding assignment 4.
Yes, worked out.
Yes, worked out.
Sir, in question number 8, I have doubt regarding Z
8. Okay, let me see.
Question
ZD.
8.
I have not solved
Okay,
it.
let me see.
I have not solved it. Let me open the assignment. Give me a minute.
What? Okay, I'm not solved. Let me open the assignment. Give me a minute.
Yeah.
Yeah, L, what is the doubt in question 8?
Should
Sir,
we?
even I also got the same doubt, sir.
Yeah. What is the doubt?
Yeah, what is the doubt?
Sir, when I have evaluated, I got the answer as minus 0.566803, sir. And
Okay.
as 0.556 is the approximate one, I have chosen that one. But the correct answer given was 0.522. And twice I solved this problem, sir. And I have included GMB also in solving this one.
Okay.
Okay.
Sir, if you
So,
permit, I'll mail this solution to your email ID, sir.
Okay, you can
okay,
email
you can email me,
for
and
this. You can also
for
post
this,
in
you
the.
can also post in the.
I think you have that
I think you have that
forum where you can raise
forum
questions.
where you can raise questions, right?
Yeah. If you
Okay.
post that, the
Yeah. If you post that, the
will look into it.
concerned
Like
team will
if
look
there is
into it,
any
like if there is
problem with the
any
solution,
problem with the solution,
like if there's problem
Okay,
in
okay.
like if
the
there's problem in
answers. So
the
if
answers.
that is true
So
for
if
all the students, they will correct
if that is true for all the students, they will correct it.
Okay, sir. Okay.
Sir, I am having doubt regarding ZD. In this question, we have to find
it. What
ZD.
is ZD?
Uh,
What is ZD?
sir, can I show my screen? Share my screen.
Not sure.
I'm not sure if this is possible.
See.
Let me see.
Are you able to share your
Are you
screen?
able to share your screen? Can you try?
No, sir.
Can you try now?
Okay. Can you try now?
Yes, sir, yes, sir, I can try. So here, this is the ZD. I'm getting in numerator. I'm getting there's one more term in addition with this. That is GM 3 times RDS 3 times R.
Okay.
Okay.
Can you solve it right now so that I can find where I'm getting
Uh,
wrong?
did you try
Did
the
you try the with the method that I had
last
taught
class?
in the last class?
Yes, sir. I had tried, but I thought I should go with another approach like this,
Okay.
which is given
So
here.
I'm not sure
I'm
of
not
this approach.
sure
I
of
have
this approach. I have not
read it, but
read it, but
if you want, I can
if you
try
want, I
solving
can
it with
try
the
solving it with the
method that I had taught.
method that I had taught.
Okay, sir. If you can find ZD with your approach, can you do this?
What is ZD? The
What is
resistance
that?
at
The
drain.
resistance at drain. Which drain are they talking about?
Is ZD the resistance at the output node V out?
Is ZD the resistance at the output node V out?
Sir, this whole M3 and R.
Okay.
Okay.
That is true.
Sure. That
What
is
is the
true.
resistance at
What
source?
is the resistance at source? Okay. So, anyways, so let me try
Can
to
you
solve
stop
it.
sharing your screen?
Can you stop sharing your screen so I can share mine?
Okay, sir.
One second. Okay.
So what I did last time was
So what I did last time was I gave you some equations, right? Where are those equations? plus
So we will
so
use the
we will
same
use the
equation.
same equation. So above we have PMOS,
And
NMOS.
so let's say the
So
current
let's
is
say the
ID.
current is ID.
First I'll write for
First I'll
PMOS
write for PMOS,
equals to
ID equals to
GM. What is
GM. What is
VSG?
VSG?
This is
So
drain.
this is drain, source, gate.
Let us say this
Let
is
us say this
VX.
is VX.
GM.
GM. Okay.
Sorry, PMOS source is about
Sorry.
source.
PMOS source is above the source. Yeah. Fine.
Okay. GM
Okay.
minus
GM
V out
minus V out
GD
plus GD.
VSD. VSD is
VSD. VSD is minus VX
plus GMB
plus GMB.
VSB.
VSB.
VSB is 0.
VSB is 0. Okay.
This is our first
So this
equation.
is our first equation.
Second equation is,
Second equation is okay.
okay, let us write
So
what is
let us write what
VX.
is
So
Vx.
VX minus
So
V out
Vx minus V out
by R is
by R is ID.
so
So
VX equals to
Vx equals to
IDR
IDR
plus V out.
plus V out.
So we
Okay.
know
So
VX
we know
also.
Vx also now.
Now let us
Now
move to
let
this
us go to
transistor
this transistor M1.
ID equals to, so this
ID
is
equals
first
to, so this is first equation. This is second.
third is
Third is
ID is
ID is GM.
VGS here
VGS here is let us VY. GM.
V minus
V minus VY
plus GD
plus GD.
V out
V out minus VY
plus
plus
GMB
GMB.
VBS
VBS.
VY.
VY. So
Minus
minus VY.
third.
Third.
Fourth
Now
equation
fourth equation for this M2.
ID is
ID is equals to
GM
GM
VY
VY
plus
plus
GD
GD
VY.
VY.
Okay.
Okay.
So
So
from here we
from
can
here
get
we can get
VY
VY equals to
ID by
ID by
GM plus
GM
GD.
plus GD.
Right? Yeah.
Right?
So
Yeah. So I'll put,
so I'll
let me
put
call it
this
4.
in
So I'll
this
put
equation
this in
and
this
I can
equation
put this in
and
this
I can
equation.
put this in this equation. So
Yes.
let me just see.
Fine.
Copy it.
GM V minus ID
GM
by
V in
GM plus
minus
GD
ID by GM plus GD
GMB.
plus GD.
GMB
Plus GMB
minus ID by
minus
GM
ID by
GD.
GM plus GD.
But what do we have to find
But
here?
what do we have to find here?
We already find.
What is V order? Fine.
So now
So now let us call it
what equation are we at?
equation. What equation are we at? 5.
And now put
And now
this in
put
equation.
this in this equation. So we will get, let me copy this one. Delete the CO part. ID
GM minus
GM
V out
minus V out
plus GD
plus GD
cancel out IDR plus V out
Dx is what? IDR plus V out.
minus IDR minus V out. So
So
now
now
what I will do is
what
I
I will
will
do is
equate
I will
equation
equate equation 5 and 6.
so minus
So minus
GM
GM V out
minus
minus
GD
GD
IDR
IDR
minus
minus
GD
GD
V out
V out
equals to
equals to
GM
GM V in
minus
minus
GM
GM
ID
ID by
GM plus GD
GM plus GD
plus
plus
GD
GD V out
minus
minus
GD
GD ID by
GM plus
GM
GD
plus GD
plus
plus
GMB
GMB,
minus GMB
okay,
ID
sorry,
by
minus
GM
GMB ID by GM plus GD.
we have to find
So what do we have to find? We have to find, okay, so there is one issue
still have
still.
ID that
We
we
still
have
have ID that we have not eliminated, right?
how can we limit
How
ID
can we eliminate ID?
Sir, we can put the value of Vx in first equation and then find the ID.
yeah right
Yeah, right, you are right. Let me just put it back. So
ID
ID
1 plus
1 plus
GDR
GDR
equals to GM
equals to GM
minus GM
minus GM
plus GD
plus GD
V out
V out.
so ID
So
is
ID is
minus
minus
GM
GM
plus GD
plus GD
V out
V out by
plus GDR
1 plus GDR.
so
So
I don't
let
need
me just erase this now. I don't need to solve this
I
completely
can
now.
just put this value of
So I
ID
can just put this value of ID
in fifth equation
in this fifth equation.
then we will get an
Then
equation
we
in
will get an equation in terms of V out and V in.
we can
So
solve
then we can solve it.
just copy this
Just
again
copy this again. So this also here. Okay.
what is ID
What is ID? ID is equals to
minus GM
minus
plus
GM plus GD
V out
V out
GD
GD
V out
V out
divided by
divided by
1 plus
1
GDR
plus GDR.
so let us
So
put
let us
this
put this
GM
minus GM plus
GD
GD
1 plus
1 plus
GD
GDR
dot
dot
V out
V out
equals to GM
equals to GM
V in minus
V in minus
ID is what so this GM plus GD
ID is what?
plus GD will cancel
So this GM plus GD and this GM plus GD will cancel.
V
So
out
we will get
by 1 plus
V out by 1 plus GD
plus GD
plus GD
minus same
V out minus same thing plus V out
1 plus
by
GDR
1 plus GDR
plus GMB again same thing plus V out by 1 plus GDR.
by 1 plus GDR. Okay.
Let us take all the
So let us
V out
take all the
terms
V out
common.
terms common somewhere. Okay.
So V out minus GM
So
plus
V out minus GM plus GD
1 plus GDR minus GM 1 plus GDR minus GD
minus G
1 plus
minus
GDR minus GMB 1 plus GDR So we have taken care of this term. This, this, this one is remaining.
This one is remaining. Plus, sorry,
GD
minus GD
equals to GM times VM.
equals to GM times VM.
Okay, so it is fairly
Okay, so it
complex.
is fairly complex now.
Okay,
Okay, so let me see V out
1 plus
1
GDR
plus GDR
will be
minus GM plus
minus GM
GD
minus GM minus GMB
B
G
minus GD into 1 plus GDR
equals to GMB.
plus to
So this
GMV.
GD and this GD will cancel.
So this GD and this GD will cancel. So we will have V out, let's say,
GD
minus
minus
G
minus GMB.
minus
Sir, I think
2GM
we are doing one
minus
mistake.
GM.
Value of GM and GMB are different for all
Oh
transistors.
my god.
Oh my god.
Okay, so I'll need to solve this completely
Okay,
again.
so I'll need to solve this completely again.
What I will do
So,
is I'll try to solve
so
this
what
and
I will do is I'll try to
post it
solve this and post it
in the comments
in the comments in the
will that be fine?
video that I upload. So will that be fine?
We are already overshooting the
Yes, sir.
time.
Then we are already overshooting the
One thing
time.
that I'll suggest you is
And one more thing that I'll
if
suggest you is
uh,
do
an
if you
answer,
feel that some
do
answer
post it in that chat forum
is
that where
wrong
you
at
can. I think it is
where you
when
can
you
I
click
think it is you
ask a
when you click
question
ask a
in that
question in that tab. Let me show.
Sir, I think one person posted it, but did not get any response right till now.
okay. So
Okay, so I think if more of you post, then I think
we will get
you
a
will
quicker
get a quicker
resolution. I'm
resolution.
not
I'm
sure.
not sure.
Uh,
I'm not.
I do not
I do
handle
not
that
handle
part,
that
but
part,
yeah,
but yeah,
I'll try
I'll
to
try to do.
I'll try to ask someone to look into
I'll
that.
try to ask someone to look into that.
And yeah, it would be better if
And
some of
yeah, it would be better if
your
some of you
solutions
could
also there,
post your
so I can
solutions also
go
there,
through them
so
once.
I can go through them once.
Okay, sir.
Okay.
I'll try to
I'll
solve
try
it.
to solve it and post it.
Okay, so
Okay, so
should we end for
should
today?
we end for today?
Okay. Thank you, sir.
Okay.
Okay.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you.